Hello. This is summation of my assignment 2 presentation paper reading. So, my topic is deep semantic dictionary learning for multi-level image classification. And this paper is talking about the issue of classification of multi-level images with the help of deep semantic dictionary learning solution. So, first of all, I will talk about what is multi-level image classification. So, this classification image object can be categorized in more than one class. So, we generally we do single label classification, and we have to classify those images which have multi-level co-occurrence dependency, because in one image there are multiple occurrences of object, and high order correlation because one label is correlate to another picture, and another picture is related to another picture, so they are internally correlated with multiple objects, and they are semantic redundancy. So in this paper there is the example like this image. So here's the example that above you can see that they are single label images, and that is actually like board person. This is from ImageNet, and below you can see there are multi-level images from Pascal POC. And because in the same image you can identify there's a person in motor, person in motor car, and dog with sofa. So this way we have to identify multi-level images. So we have to train with that and classify that images. So for this paper, what are the related work which is actually done? So problem done earlier this way. So first is a problem transformation method, and in turn problem transformation method, a large number of classifier have to be trained for multi-level classification tasks, which obviously actually reduces the efficiency and predictability of model, and introduces the parameter redundancy problem. And for the algorithm adoption method, this actually regularizes the network to capture both semantic and spatial relation of these multi-level based on the weighted attention maps. And in dictionary learning, we have also studied in our course, but related to this paper, it actually effective tool for exploiting correlation between label and visual spaces in the field of image annotation. So that helps in multiple instance learning. Further, there is a multiple single label classification, and actually it actually failed to model the dependency between multiple labels. So yeah, it's just a pre-work. So that talk about the failure of this, and also graphical model, which is actually in which we large amount of parameters. They are large to solve this issue multiple classification. There are large amount of parameters, and that is not good for higher order code. Further, let's formulate the problem as per the paper. So in multi-level classification, it's actually more practical and challenging things compared to single level. And in simple semantic-based market, it takes the information for a visual representation. We'll further see in a diagram how this can be exploited in a visual representation. In multi-level classification, there are objects which are located on different position and different scale. So that is a major problem because sometimes object is not able to classify it because it's on a different scale and different position, sometimes not visible clearly with blur things, and have different composition and interaction with the between the objects. Sometimes there are such level of interaction. Some objects are not clearly visible, so it actually increases the complexity for such kind of things like multi-level image classification. We have to study how it can help in deep semantic dictionary. How what is DSTL, deep semantic dictionary learning, and how that can help in our paper. So this paper actually mainly use feature learning, and that use AsNet when you pre-trained on ImageNet. So from which we are actually learning features. Second form of this thing is semantic dictionary generation. Actually, this generate and autoencode from the nonlinear text and in the NLP way. So further we will see how autoencoders and other transformers can help in the formation of that semantic dictionary generation. So in DSTL, actually, it's a terrible deep learning model which incorporates the semantic information category and provides a native but elegant way to exploiting and reconciling the label, and which actually have the visual spaces. We can understand with this uh, model picture, which is actually showing the flow of semantic dictionary learning. So here we can see in our part that there's an image which actually going in the ASNet for feature mapping, and that feature mapping is going through the global max pooling. In the second part, which I discussed here, that semantic dictionary generation, that semantic dictionary generation having the lot of word like a lot of classes and words, and that's going in a globe, and that globe is further doing word embedding, auto encoding, and semantic dictionary, and that process is going again and again for dictionary generation. And what the dictionary it generates, that combines with the global max pooling, and actually it visualizes the feature for representation. Further, this whole model goes into the least square method, and that helps in the multi-level classification, where we pass the image for testing, and that learns the feature from feature learning, and that actually pass through this visual feature representation which we created in this part. So, other than this, there is a parameter updating strategy while we are implementing this learning generation via DSTL. So, how it helps? It actually optimizes our model, which consists of our presentation coefficient, updating, and semantic dictionary stages, executed alternatively forward, and backward propagation. And actually, in backward propagation, it used to optimize the dictionary D, which in the part of feature learning model. So how actually experiment happen? This details about that. That actually pre-trained the ImageNet with Azure 101, and for feature learning model, which actually we have seen in the image. And the autoencoder part consists of fully connected layer with output dimension of 1024 to 042 ILU with negative slope of zero point 0.2. All modules are optimized with stochastic gradient SGD optimizer and the momentum of 0.9 with weight decay of 10 raised to power minus 4. The initial learning rate is 0.04, but actually it decays by factor of 10 for every 40 epochs, and network is trained with 100 epochs in total. These are all the experiment details which happen in this paper. Further, there are experiment results how this happens. And DSTL actually achieves the best performance in map in all the three data sets which is used in this paper, and is the most important composite performance indicator in multi-level classification. On COCO dataset, DSTL achieves the best performance and MAP CF1, and which are all the most important performance indicators. So compared with the plain ResNet 1.0 model, DSTL get 4.4% more accurate in map, which validates the effectiveness of this paper. So here we can see how all the four models, pre-trained models which are used in this paper: Pascal POC, MS COCO, Pascal in the performance of this A and B, and performance with different values of lambda, and then that with geo, and this there is no regularization with this graph. So overall conclusion of this paper is dictionary learning techniques actually exploits and reconcile all involved spaces, including labels, semantic, visual spaces, to generating the semantic dictionary and taking the reconstruction of visual features as a dictionary query. Task to obtain normalized representation coefficient as label occurrence probability. There can be some improvements. One of the improvements is this: DSTL multi-label classification further can be improved on multi-model classification for unsupervised classification of unseen images data, where same approach will follow up on the all inputs model to give better final results. Uh, Here we end, and thank you so much.